Good afternoon. It's always tough to follow great speeches and great other presentations, but it's even more tougher to follow lunch. And I'll do my best to keep you awake. It's that lunchtime drag that'll hit in, and I appreciate it. And I know I've been there on the other side. So a little bit about the presentation and about myself. We're going to be talking about a golden ticket to the cloud, some common and novel ways we've been seeing threat actors kind of attack the cloud. I'm part of Mandiant incident response firm, and I'm a senior manager with our response team, specifically around remediation. So, give a quick introduction of myself, a little bit of background, and specifically around Mandiant, kind of what we do here, and a little bit about what the threat landscape is looking like from what we're seeing from the incident response angle, as well as the kind of proactive assessment type angle that we do, and some of the common attacker methodologies we're seeing. And then I'll bring about a little bit of a kind of novel technique we saw certain threat actors use a few years back. That's still fairly novel. Not a lot of people are using it, but we're going to introduce the novel technique and then also bring in ways to detect it because of this technique being so easily performed. Once it's performed, the ability to bypass things like MFA and all these other types of mitigation techniques and security controls is fairly simple. And then I'll kind of go through a litany of best practices around the different types of domains within the cloud to try to, what we're seeing is best practices from just on the ground knowledge of these proactive engagements that we have, as well as when we're doing incident response services, how we can best make our clients kind of get in the position to win. And of course, I want to leave at least 5 minutes for introductions, for my questions and discussions. I want to keep it as free-flowing as possible. A little bit about myself. I hate talking about myself, but I guess my name is Nader Zaveri. I'm a senior manager with Mandiant, been with Mandiant for about 4 years, but altogether I have about 15 years of experience in cybersecurity, infrastructure, security, and just really overall kind of cloud security. Have about, I'm based in Houston, Texas, born and raised. So I guess there's some Houstonians and Texans around here. It's awesome. And really, my main focus is around containing and remediating. So during an IR, so as you're probably well aware, so Mandiant's that foremost leader in incident response services. I always kind of let everyone know. In the past 10 years, if you've heard of a major breach that's happened that hit the news wire, a good conservative number, about 70% of the time, it's usually us investigating. Of course, we are not always allowed to divulge. We never divulge our name, except when the client themselves like to divulge it and say, man, it's here to assist. So I'm specifically in the containment remediation part. So during an IR, there's two major teams that are deployed. We have the investigative team. They're there to kind of investigate what's happening, what's with the threat actor, how they got in, how are they allowed to move, privilege escalate, exfiltration of data, anything like that. And then really my team is there to, as that's happening and understanding the incident, we're here to contain, remediate, and kind of kick out the attacker. So as we're understanding the incident, we have to plug holes fairly quickly, finding out misconfigurations, and then being able to prevent it when we are trying to kick out the attacker. And one of the main things specifically with myself is I've been really focused on cloud-based IRs. I'm part of the IR team, so I do help with investigation, but also containing and remediating. A second full thing that we do, specifically with my team, is we don't only do incident response. We also do proactive type engagements, security assessments of the cloud, and cloud configuration. So I'm able to kind of see what is happening. You have a very jaded view when you see only the kind of bad side of cybersecurity, where you only see people when they are having to respond to an incident. But I get a chance to see kind of those proactive teams where they really want to see how they're doing in terms of their cloud infrastructure and how they kind of fare with other organizations similar in capacity and their organization. So I'll be talking about that throughout, kind of giving sprinkling my own anecdotal experiences. And of course, housekeeping items. I'm going to try as best as I can. I'm going to be mentioning a lot of kind of real world scenarios that either I've personally done incident response services, people in my team have done, or just kind of public knowledge. I'll try to obfuscate a little bit on the details, just so it's not pinpointing back out to the specific client. Because some of these are incidents that are not publicly disclosed on the method and attack techniques. So kind of wanted to kind of talk about the cloud threat landscape. As cloud is growing, this is one of the big things that are happening, and we're seeing this a lot, is the rapid growth into the cloud, especially post-COVID, right? When COVID hit, there we saw an influx, just from my vantage point on the incident response side, influx of cloud-based IRs, because we're hearing our clients go to the cloud. Sometimes they're going in the cloud in a more rapid fashion. They're not used to having everyone being a remote workforce, so they had to find ways to make things work. It's totally understandable. It's operations. You have to maintain the operations of the business. But then with that, there was a lot of security misconfigurations. People were just kind of getting into the cloud all willy-nilly. They were just lack of kind of some of the key things within a cloud, just basic misconfiguration steps, certain things that are, you would want to turn on by default were not being turned on by default. And, there's a lot of things where there's a lot of services that a cloud provider, we're talking about AWS, GCP, Azure, that they provide base security services that, it's just a matter of enabling for the people to be able to utilize it. But a lot of times that doesn't happen because of lack of awareness, and also there's a issue with money, right? Everything you turn on in the cloud is going to cost money, and they try to find the best way to have the best bang for their buck, and a lot of times security is kind of pushed off by the wayside. So some of the cloud statistics we've seen, and then this is actually a little bit older data, I have to kind of update this specifically, is around the really last one, around 11%. I would say this is 11%. The data is a little bit higher now, but just anecdotally speaking, I know that I have a unique position, so a lot of the cloud-based stuff is coming in. I will be able to have the visibility on. But even I was talking with other people in other IR firms outside of Mandiant, and they've been seeing an influx of cloud-based IRs. They were seeing a lot of threat actors start attacking cloud infrastructure, misconfigurations. I have a whole different article around instance metadata service, around AWS and Google and Azure, and how they would attack that from the outside. And there's a lot of now added risks that are happening within the cloud, which of course, everything will have a risk. It's just a matter of mitigating and trying to reduce the impact. And most of the time we've seen is most organizations, as you know, patching is still an issue. One of the things that we've seen actually with ours is critical vulnerabilities. Critical vulnerabilities have been one of the big reasons why certain different organizations are being impacted the most. So a recent study that we did with Mandiant, when we have our M-Trends 2022, where this time around 18 months, is we were able to see that instead phishing wasn't the initial attack vector that got people. Normally you always hear about phishing training. The biggest training was third party and vulnerabilities. So thinking about the various vulnerabilities you have in your environment. And patching you can only do so quickly, so fast, especially when it's in production. That was actually the highest method of how threat actors were able to come in. Majority of cloud security failures happens at the customer's responsibility, right? You're always taught the responsibility matrix and where your responsibility ends and where the cloud provider begins. But majority of the time that we're seeing is it's a misconfiguration from the client, that if they had this enabled and disabled, then the threat actor was not able to come in. We're having this across the board with even some threat actors being able to abuse across cloud providers now. So one of the IRs I was just on, the attacker was able to get in to AWS through instance metadata service, misconfiguration, of course, on EC2 instance. And from there, when they were able to go and get their GitHub repo, which was on there, then they were able to scrape credentials and find Azure credentials. They went and laterally moved into Azure, started to do logins at Azure VMs. Luckily, they had better security Azure VMs because they had some EDR solutions. They were able to block it. But the ability for threat actors now are just not focused on one cloud provider, which maybe a year, 2 years ago, you used to see if they're hitting AWS, they're just hitting it hard, and then that's kind of where their playground will be, or Azure. But now we're starting to see where threat actors are now able to kind of maneuver across, and just the threat actors' knowledge of the cloud is getting better. We definitely have to kind of up our game as well on making sure credentials aren't in GitHub repos and things like that. And this is the M-Trends report that we specifically did just on the cloud. As I mentioned, in 2022, well, those numbers have changed drastically, especially when it comes to the initial attack vector. But really, when we focused on just looking at cloud-based IRs, lack of cloud adoption, threat detection and response. So I'm gonna focus heavily on detection and response, specifically on how to detect this certain kind of novel method, the Golden SAML method, and attack utilizing hybrid environments, right? If you have the same credentials and you're using on-prem and you have the same credentials going in the cloud, it's just a matter of one of them to get popped and they'll be able to maneuver. So that was kind of a lot of the initial things we used to see early on 2-3 years ago, was the maneuvering from on-prem to cloud, cloud to on-prem. But as I mentioned, now they're doing cloud to cloud, and it's all about scraping credentials, trying to find it. Because as we know, identity is the new perimeter to the cloud, right? That is the new perimeter. It's no more the rooms, the on-prem, the data centers. It is the new perimeter to the cloud. So knowing that, having the granularity in policies and specifically around IAM, that is where a lot of this can be kind of fixed, and a lot of permission issues can come about. So I want to kind of talk about a little bit common attack methodologies. So what we're seeing from the common attack methodologies is not, this next one is really not an attack methodology, more than the fact is when people are getting into the cloud, especially this is more so the case a few years ago, but still we're seeing that now, is the rogue IT, shadow IT methodology. What we're seeing is DevOps is the first to get to the cloud, right? The cloud is very nice for people who are in development, people who want to have that agile nature of trying to spin up apps. All I need is a credit card on my department. Now I have a bunch of applications. I don't need a rack and stack and have a server and have virtual machines. I could just do that in the cloud. And this is where we're seeing a lot of organizations kind of, when we come in to do our security assessments or during an IR, the security people on the team have no idea what's happening in the cloud, or they have very little visibility because of the DevOps. Yeah, they handle it, and they supposedly handle security. We all know how much developers care about security. It's a hindrance a lot of times, especially when they want to make things go, just give it admin rights, and let's see if it doesn't break, then that's good, right? That's kind of the way, as long as my application is running, I don't need to worry about granularity permissions. So we started seeing that a lot, and if you recall, I'm old enough to remember back in maybe 10, 15 years ago, where shadow IT was a big problem with on-prem IT, where there was a big things around, especially around hospitals. A lot of the clients I had were hospitals, and each hospital wing had its own kind of IT department, not just racking and stacking or putting up a small closet, network closet, or a small like desktops being deployed, but they had their own fully functioning IT where there was no centralized way of seeing security across the board. And this is something that we're starting to see right now happen in the cloud, just because, like I said, the cloud is very interesting to people who are attackers because of the ease of nature from the outside, but also for my developer, it's something that, hey, I want to be able to get into the cloud. It's easy. I can just spin up. If my application is running a little slow, just put some meat on the servers and get it more faster. And one of the things we're seeing is a lot of internet-facing remote management. So as COVID had increased the cloud influx, they still had to perform management functions. IT admins, they're starting to seeing a lot of externally facing RDP instances, externally facing instances that had SSH open to the world. You could be shaking your head right now, but I'm pretty sure we all have heard of this throughout just the various, speaking with everyone, or just even in your own organization. And of course, the unpatched applications that are happening, it's not only applications that are on-prem that, hey, you have to have at least initial access to come in to be able to exploit this vulnerability. This can also happen Jenkins servers always getting popped and things like that. And of course, admins being notoriously lazy. They love to always create backdoors. I was a system admin, so I can kind of tell you being lazy is part and parcel of being a system admin. It is a badge of honor. When you are the laziest system admin, that means you have automated everything, you've done all the back things, as well as created some backdoors just in case if you get kicked out, because you always want to plan for the fact that things aren't operational. I want to still be able to get in. And that's one of the ways we've been seeing. And of course, phishing. One thing when we're thinking about cloud, you kind of forget about phishing a little bit, right? Because a way to access the cloud is still through your endpoint. You're still accessing through your endpoint. So if you were to get popped with a phishing campaign, which everyone has had either gotten through a phishing campaign or really gotten popped, then the possibility of that threat actor being able to scrape credentials from your actual system. If you're an admin of cloud or DevOps person, then you're starting to see a lot of credentials, SSH keys, access keys. When you're looking at GCP and Azure and AWS, you have access. You download those access keys to get on. And threat actors are starting to now, once they get into a specific endpoint, they will start scraping the credentials and finding out if there's any IKEA keys, right? Things that are long lived in AWS and things like that. Another one is kind of endpoint exploit. Of course, there's still the one I want to kind of always want to focus on is when we're thinking about the cloud, we're always thinking about that cloud infrastructure, what's happening in the cloud, but also what's happening at your endpoint is very important. Make sure your own endpoint is secure with the right level of security, with the right level kind of zero trust capabilities. But also, when you have your endpoint and when you are, one of the things that we always kind of mention, especially if you're getting into the cloud, is to have a privileged access workstation to log into the cloud from there. So you don't have those credentials sitting in your own day-to-day machine where you check your emails, you go research something, and that gets popped, and then guess what? You are compromised at a larger degree. The credential compromised via public exposure. This happens. Probably one of the most common techniques in the cloud for us is credentials getting exposed, getting leaked on the internet. Your GitHub, you're on GitHub. We've seen where a GitHub credentials get exposed for just a private repository gets exposed for just an hour. That's all it takes for the Google crawlers to go out and Bing crawlers to go out and start to cache the page. So they quickly found out, oh, let's make it private again. But the threat actor was able to go through the cached pages and see the credentials and then get in. And it took us the whole fiasco of having to go contact Google, having to contact Microsoft and all the different browsers that have those crawlers and ask them to remove the cache page. It's just made the instant response take a lot longer, and we just have to be very careful, being able not to have any sort of code committed. And we'll talk about that and what are the methods of that. The cloud platform service hijacking, right? This is where, if there's like externally exposed APIs, you have vulnerability in an application, you can use serverless. So this specific one, if you ever get a chance to watch a video on a really cool cloud-based attack around serverless, it's called Gone in 60 Seconds. Great topic. But this is kind of the gist of it, where they were able to get those externally facing APIs, once they got in, they are able to create a specific function that were able to post kind of valid keys and sessions. And once they were able to do that, they were able to get into the application, set up their externally facing, let's just say they have their own cloud provider or their like DigitalOcean or whatever they want to have, storage bucket, and then start being able to exfiltrate those to the externally facing storage bucket. Hybrid cloud lateral movement. That's another one. We've talked about it a little bit. Is if identity is the perimeters of the cloud, and a lot of organizations, they are getting into the cloud, especially if you're using, let's say, Azure, right? So you're having the same permissions as your Active Directory on-prem. What we always kind of recommend is if you have anyone who is an admin of Azure, right? People, global admins, server admins, service admins, user admins, the various different roles, even security reader, always want to have a separate cloud-only account. So then those are not if one gets popped, the other is compromised, and vice versa. Because we see a lot of people that get, if you're a domain admin on-prem or an exchange admin on-prem, I've gotten domain admin rights at one point in time. You will most likely then have that global admin role, and then for an attacker to easily exfiltrate data and just kind of maneuver in and out of the cloud is something that we've seen a lot. And that's one of the things. Always have a separate role. If you are SSOing, make sure that credential you're using is not associated with actually an on-prem privileged credential still. And third-party library supply chain attacks. So this is something, when putting this together, this is what we've been on the end of. I helped write an article around this late last year around NPM and the different vulnerabilities. So what we've seen is attackers are now saying, let me get the best bang for my buck. The best bang is let me get into one of those libraries that everyone uses, like one of the NPM libraries here, and let me put a backdoor into that library. So when you are loading your software, loads packages and libraries automatically. It's going to load the old one. It's going to load the malicious one. And what happened was, turns out the guy had his GitHub credential compromised. That was compromised, and the attacker was able to get in and then put in their malicious code. And then remember, it's a trusted library that the application has been using every single day. And the way, if you're using a lot of microservices and containers and Kubernetes, it reloads the application each time just from the ephemeral access. And the attacker was able to have a backdoor into hundreds of applications across various different organizations because of the rampant use of that NPM library. And not just picking on NPM, this is really with anybody who has using libraries to create that. You have to have a way to review and the person who review each of these things. And how can you do that when you have hundreds of applications? Each application has a dozen libraries that are actually loading into memory when they are loading the application up. A few other ones, externally exposed EC2 instance, S3 buckets or storage blobs within externally facing. Sometimes that is by design, sometimes that is not by design. It's accidental misconfiguration, or sometimes it is, hey, we want this bucket to be exposed because we have a website. That website needs to get images, and the images comes in from S3 bucket, which is very common. But once we need to make sure that what is in that S3 bucket is exactly what it's supposed to be, as opposed to not. And the on-prem to cloud pivoting, as well as third-party application. And this gets into the more novel method that we came out. So the Golden SAML attack. So the Golden SAML attack, a little bit of background about it is, it was first created by the folks in CyberArk Research Department. They had created this attack back in 2017 about ways what you can do to have a Golden SAML ticket, which then allows you to get into infrastructures that where you are using a federated service like an ADFS. They had also created a program with it as well. And really, it just allows you to get in, and once you are in, you can get into every single cloud, especially if you're using a federated method to log in. And so to understand the Golden SAML technique, I think we have to really understand what is SAML authentication. What we will do is, there's three major entities, right? You have the user person who's logging in. He logs into the service provider, like AWS, and if you're using a federated service says, hey, I'm not handling the identity. Let me send it over to my identity provider. And identity provider then says, okay, what is your credentials? Okay, let me just double check. It's looking good. Okay, we're going to go give you what is called a SAML assertion ticket. And it's saying, yep, this guy's all good. Let me just let you know he's good to go. And then it will unlock your ability to get into the cloud or whatever service. This is really across. You see SAML authentication all the time. When you log into your bank, you'll see SAML auth. If you ever get a chance to look at the URL when you're logging in, SAML authentication is kind of everywhere. It was two SAML. I think the first SAML came out, 1.0 came out around 2002. This SAML authentication that most people utilize today is SAML auth 2.0, which came out around 2005. So knowing the method of the Golden SAML of SAML authentication, what happens during a Golden SAML attack? So we have three major entities still, right? We have the attacker instead of the user, it's the bad guy. The bad guy, the identity provider, and then the service provider. So one thing is, it's a reverse. So in order for this attack to be successful, they already have to have access into your identity provider. Once again, the identity providers are fairly high up on the tier list in terms of your priority, your criticality of applications. So you're looking at a very critical application. So they have already almost God mode in your domain. In order for this to happen, they have already initialized, they've already privilege escalated, they've already laterally moved, they've already did all the major techniques. This is now to maintain persistent access and also to bypass MFA. You're going to see the way it comes about. So one thing is they first go into the identity provider and they extract all the specific credentials or certificates. There's a specific function you could utilize, and dumping certain utilities across the board and having everyone's capability of logging in. So that once they get that, they'll log into AWS or whatever cloud provider you want to go, and AWS says, hey, I'm still trying to log in with this identity provider. What they do is they insert what is a forged SAML assertion at this time. So when it's going through that, they're going to insert their forged ticket SAML assertion that happens, and that will then trick the MFA provider saying, yeah, this is the service provider saying, yep, this is already coming in. MFA has been satisfied, and then they will be able to get into the specific service provider. So knowing that technique, right? So now we know kind of the major methods. Let's create some detection and alerting. So we know how SAML works. We know how Golden SAML, the methodology is. How do we create this type of alerting that has to happen? One thing is, you have your identity provider. You have your user. So of course, you're getting stuff from the user agent in the middle, but you also have the identity provider, and you have the actual service provider, which is, we're going to use AWS for this example. So you want to make sure logging is turned on at your IDP. So this is regardless. So this could be ADFS, ping federated. We're actually going to use ping federated as an example because during the Golden SAML attack with the people who utilize SolarWinds, APT29, they use Golden SAML. They use that against ADFS. So that's fairly common and that's fairly talked about a lot. We wanted to kind of focus on a different IDP, which is like ping federated, but I think this can go across any specific methodology. Detecting on the IDP, ensuring that there's advanced logging at your IDP, as well as the AWS service that we're going to utilize. And then, of course, correlation. So you want to first detect the Golden SAML. You have to understand the data sources and then do the alerting. So when we are looking at the data sources, right, what type of data source we're looking at? Log on events at your IDP and log on events at the service provider AWS level, right? You're going to look at when a Kerberos, like for example, if they're using ADFS, for example, we're going to use ADFS as an example of if they're using Active Directory, federated services. When a Kerberos ticket is being requested and a new credential is created, we know that's 4769. So that's going to have that. It's going to have a 4769, but also along with that, it'll come in with an IP address. The IP address should be pointing to your IDP. If it's not pointing to your IDP and it's pointing to a non-IDP source, that's a possibility of where you'll get a malicious actor trying to log in. Then you'll have, of course, within ADFS, you'll have the specific advanced auditing function, which you can have those 1200, 1201, 1202. When the credential is being federated, you'll be able to also see if they're using a dump, like a certain util dump, you'll see that in the event name and the specific event description of what's happening. And then when creating alerting, we're going to actually create a quick alert a little bit later. But when we're building out this detection, you want to know what's happening at the cloud service logs, right? We're going to use CloudTrail logs specifically because we're using AWS as an example. But look at the events in the CloudTrail logs for logins, what happens when your IDP logins. So you have to, of course, have a baseline. You have to know how events are happening when a general, legitimate user is logging in order to catch things that are anomalous. And your IDP logs, looking at the events specifically related to logging in to your service provider. How does those look? What IP address is happening? What is the username that's being provided? And what does the username look like inside the cloud provider, right? You want to be able to create that, and we're going to actually go through some Splunk queries to kind of help people put that together. And of course, aggregating both across by the user, and then filtering out based off of MFA sessions. As I mentioned, MFA will be set to true because if it's going through your IDP, it is thinking you've gone through the basic methods of authentication. So for this example, we see this is the login showing an IAM user logging in and making through AWS API calls, and here's kind of the user. And then on the right side, we have at your IDP level. You're logging in with your IDP, you have an IP address. Sometimes the IP address could be coming, depending on the way your network is configured, the natting and the rules. It might be different each time. So knowing how that is, but you'll normally coming in from your IP, your general IP, and then also what is that? So with this is you see two different, during the Golden SAML attack, you'll actually see two different users logging in at the service provider and what is being said at the IDP level. Because the person who's asserting it, they're going to be using all types of credentials, right, just to get bypass the initial authentication phase. So when we're building out this alert, this is of course Splunk-based queries. You want to create your event types in AWS across, as we saw, API calls, all users within the past hour that have logged in, making sure we're not saying we're not using the AWS account, assume role, right? We're not doing assume role permissions, and we're making sure the source is not coming in from a AWS internal address or 10.0 address. We want to make sure we want to go look at specifically coming from the IDP. And then, of course, showing the user identity with MFA session equals to true. As I mentioned, you will see the true here. And then when you go into your identity log, so this is specifically around ping, right? So ping federated will have what we have an auth attempt log. This is kind of the advanced alerting and logging function with ping federated, where you can see people logging in, and the way they're logs with ping federated and some other IDP, you want to kind of put a fairly large. We put 5 hours usually when we're at various clients when we're doing these investigations, to be able to see all the logs that happened in the last 5 hours, but specifically in CloudTrail because it is fairly instantaneous within real time and within 15 minutes, you'll be able to see that. And once you have that, you can combine, coalesce the users from what you see at the user, at the IDP level, and also at the AWS level. And when you're aggregating it across different indexes, right, you want to be able to say, I want to be able to see how many users have logged in from ping, how many users logged in to my AWS, and especially if you enforce SSO across the board, that should be a fairly similar number. And you want to make sure that specific IPs and source IPs that they're logging in from is the same source IP that you typically have. And when you're doing the final result, you'll be able to see, using the lookups, you will be able to see where AWS has been accessed to API, via API, where MFA has been allowed and not allowed. And then you'll be able to filter out those that had a bypass. So we've done this a few times with various clients since kind of the Golden SAML has been very coined and famous. One of the things kind of going through, just seeing the methods and the MITRE attack methods, seeing where the forced token is happening and the active directory configurations are being changed for the federated service. You're seeing, when that happens, what are the methodologies of remediating, right? Ensuring that the token signing certificate is rolled, but making sure you roll it twice because there's a copy that stays in Azure. So you want to roll it not just once, but you want to roll it twice. And this is a common technique of remediation that was kind of overlooked, especially early on, because still everyone's fairly new on the way this attack is. So remediating is always a kind of a win. It's always a trial and error situation. And turning on, as mentioned, advanced auditing functions with within ADFS, but also your identity provider. You should have some advanced logging capabilities where you could see the specific logins that are happening, where is it happening from, and what specific service it is happening to. And then privileged account management, we mentioned that, which is if they are getting to your IDP, the privilege account that they should have already multiple privilege accounts to get to that your level IDP. Especially what we always say is keep it at your tier zero application being your domain controllers, your ADFS, your certificate authorities, those that are critical to the domain itself, right? So not just critical from an application operation standpoint, but critical to the domain. If you have any additional kind of information you want to go look up with this specific threat actor, we just came out with a version 1.3 of this in our recent white paper. It's on remediating hardening strategies across M365. It also have ADFS, the Golden SAML attack. We just updated it, and what we did was actually coalesced UNC 2452, which was our nomenclature for this group that performed the SolarWinds attack, and now we've made them into APT 29 after multiple times of having different techniques and finding out, yep, they're exactly indeed APT 29. So I wanted to kind of go through various security best practices across the different methodologies of the cloud. Starting with governance, right? The governance is, you want to implement account guardrails. If you are in AWS, use AWS organizations and SCPs. If you are doing GCP organizations, do GCP organizational policies. Azure, same thing, resource policies. Understand the shared responsibility model. So this is something that during our assessments, we actually try to go through the shared responsibility model again, right? To understand what are you using IaaS, PaaS, or SaaS? If you're using IaaS, here are the things that you guys are really on the hook for, right? To understand that and what those services are. And it seems very rudimentary, but I think starting at the very beginning and building out that strategy early on to understand these are what I'm on the hook for. So whenever things do hit the fan, we kind of know who was the culprit and who was not. Understand the terms of contracts. Have a security contract in your cloud. So whenever you have a security point of contact in Microsoft Azure, you have it in AWS. So if they were to create, so what AWS does is they send you alerts if your credentials are found in the public on the internet. They'll give you those alerts already, and then they'll also try to make it temporary, those credentials. Best practice on IAM, of course, MFA. You've heard that, these privilege. One of the things we want to do is kind of restrict the number of privilege accounts. That's something is a tall task for anybody who's ever had to speak to clients and try to reduce that. But also this is a case in cloud, right? So the cloud is a little bit different than on-prem because the people who are in the cloud is now DevOps. It's mostly DevOps people. They're going to have a lot of privileges, overly permissive privileges, and also being able to have a multi-account strategy, right? The best way to approach the cloud is you want to have a cloud. If you have an application, each application should have its dev, its QA, non-prod, its prod set up. So then the production, the developers don't have any sort of administrative right at the production level, at least. It is done purely through pushing code through Ansible or some other Jenkins or any other method, like code build or things like that. So they're not pushing code straight to production. It's doing through a actual service or an application. That reduces at the production, then those production, of course, are the ones externally facing. So if that were to get popped, there's not a lot of like DevOps credentials that are there that are long-lived. It's all temporary credentials used by third-party applications. Of course, use temporary credentials, right? If you see anything, one good thing if you get a chance to is if you have AWS, sift through all your AWS access keys to find anything that's IKEA, right? AKIA. That is the nomenclature AWS uses for long-lived access keys. Look for that. You should see like Asia, like ASIA. Those are temporary. Knowing that, you could go through and also go through your GitHub repos. Make sure you have nothing that shows a long-lived access key. One of the things that we've had is I've had an IR where S3 bucket was compromised, probably still one of the largest public breaches of S3. And the one that got popped was part of their legacy account. When I say legacy, they're the OGs of AWS. They've been in AWS since 2008. So we're talking about long time AWS people. And of course, if you notice, if you've been following things around AWS and just in the cloud community, we've made some strides towards security, especially in the last 5 to 10 years. And that old legacy account was still up and running. When we were found out during the investigation, this is the key that was used to do X, Y, and Z. But okay, we need to rotate this key, make it not a long-lived credential, we make it temporary. We need you to then rotate across wherever this is at. First thing they said is, we have no idea what this key can go. What impact it would be if we were to rotate this key now. What are the ramifications and impact that happens? Just because it's long-lived, there's no. It's similar to when you're thinking about on-prem, right? It's like service accounts. You tell them you have to rotate service accounts, and that's the worst day of that person's life because they have no idea where that service account is actually happening. Around configuration management. So, of course, if you're using Azure and M365, you're logging in, you want to remove the ability to have legacy authentication, right? You want to be able to log in through methods that only allow MFA. Restrict access to CLI and also to the console through IP addresses ranges. So you can say with IAM policies or SCPs, if I'm logging in, I should only be able to log into this AWS console via my internal IP range or coming in from a VPN, my public VPN IP range. You can do that at the cloud, right? So that's where cloud, the IAM being the perimeter of cloud, there's still ways that you can ensure that only people from the inside can log in, right? This is where majority of the time when we are getting into incident response services, this is the big thing that's not talked about. They've never done that, and everyone can log in from anywhere, even different countries. Audit the overly permissive network security groups, as well as the security groups within AWS, of course, backup disaster recovery. Some of the application DevOps, prevent credentials from being able to be committed. As I mentioned a little earlier, one of the things that we saw was credentials from an Azure workstation being on a GitHub repo, which then they were found that out in AWS and they pivoted straight to Azure. So one of the things is, how can we prevent that? So there's various tools, and I'm all for using open source tools. GitHub has now made it publicly available and generally available for anyone to be utilizing their secret scanner, but also you can use Git secrets. And you could use stuff like Git secrets and have pre-commit hooks. So when you are committing your code, whatever developer is committing their code, it does a scan to make sure none of the specific secrets are in there, right? It goes through the various different methods of how secrets are put together. And if it finds it, it will not allow you to commit the code. It'll make sure you can remediate, and then it'll run that again. When you commit it again, it'll go through that process again until it is clean. And one thing also to think about is, and just the last week I was talking with a client about this, is that client that had that GitHub, they cleaned up all the repositories that are current. They forgot to purge all the secrets in the previous commits. And what we've seen is attackers go into the previous commit history and, hey, you cleaned it up, that's good, but if your previous commit history still has some long-lived credentials, they will be scraping that. So going through your previous commit history, there's BFG repo cleaner, there's a few other open source applications for GitLab and GitHub where you can go into your commit history as well and clean that up. And also use the Git filter as well. Data secrets and protection, one of the things we always talk about is, rotating the secrets as well as encrypting the data in motion and at rest. So depending on the way your regulatory standard requires is where kind of how a lot of organizations kind of go, right? How are they encrypting before they get to the cloud, or are they encrypting at the cloud level, right? So, this is all based off of kind of what your specific regulatory standard is. Having your own HSM and then having it encrypted by your own self is usually the best bet, but it depends on your regulatory standards that's required. And you want to also make sure the data classification. The way you could classify data is you can also tag data, especially in the cloud. You can go through, let's say, Amazon Macy and go through S3 bucket and see any PII data. Or you could go through what is automatic DLP within Google Cloud, and you could run through that, and it'll use BigQuery tags. So when you're running through the BigQuery, it can automatically data mask it and obfuscate it away. So even when you're running queries, you won't be able to see that data. And finally, kind of threat detection and response. One thing we've noticed is when they're moving to the cloud, the on-prem has been really good over the past few years of trying to get all their log sources into the SIEM. But when you get into the cloud, those cloud logs are not being forwarded to the SIEM. Or if it is, what we've seen is it's being forwarded, but it's just a pit, in this pit of CloudTrail logs. What's happening? Are they correlating their on-prem to their cloud? Not at all, right? They're just, yeah, we get CloudTrail logs in our Splunk. It's not indexed properly. It is not tokenized, so you can't really make sense of it. It's somebody has really gone through and done the kind of legwork to make it make sense. Advanced logging features, right? When you want to make sure if you have S3 logging enabled, you have server access logging, and then they have the object logging. The object logging will allow you to have a lot more granularity, so you can see the gets and puts. So, for example, we've had an IR where they only had server access logging on. So they were able to see when the threat actor was able to get into the S3 bucket, that S3 bucket had 100,000 records in there. Because they didn't have object level logging, we had no idea to tell which specific record the attacker was able to access by the way because of, when we're dealing with IRs, you have a lot of counsel, and the counsel is like, we have to say either everything, we have evidence on everything, or if we had object level logging, we could say, yep, the attacker was only able to access 3,000 records as opposed to 100,000 records, because we were able to do that. In order to resolve it, we had to go through some mental gymnastics around billing and all that. That's a long story where we were able to try to kind of make that 100,000 record look a lot smaller because of various different kind of loopholes. If they had object level login, it would have made everything a lot more easier. And that is it. With some time to spare. Is there any questions? No, I've kind of talked on a lot. Yeah, please. So we've seen a few different, right? So it depends on the level of patching, right? If let's say if it's a major potem or some sort of thing, or the domain controllers, people get scared, right? Especially if they get scared to any sort of rebooting, restarting certain things, especially if I do a lot around ICS. So I see a lot of issues around, hey, we don't want to put this down for maintenance. If this is down for maintenance, then we have X amount of time that goes down. So a lot of time is, one, not everything in their vulnerability management system, it's not prioritized. So they'll just get a bunch of vulnerabilities and, patch everything or patch nothing. And so things aren't, so this is where people who are in the threat and vulnerability management program has to help prioritize for your developers or for your server admins. Hey, these are the patches that just came out, especially what I like to say is, you don't want to wait if it's a major vulnerability that gets traction. I'm on Twitter all the time, so I'm seeing what's getting traction, what's hitting the radar. But especially when a POC hits on a specific vulnerability, that has to happen right away. I have a story where the vulnerability happened on October 21st. October 27th, POC came out. So around 6 days later, the next day, the 28th, they got popped. So if you're thinking about your patching in 7 days, right? Most patching cycles are 7 days. That's not even enough, right? If you're thinking like that, right? So, you have to be on the ball. And that's also, you'll notice CISA come out with major kind of alerts when a POC comes out and it's realized to be a legitimate POC of a proof of concept of an actual vulnerability, that's when they're going to try to alert everybody, like, hey, patch this. This is one is already high level, but now you have the script kiddies, right? So, I mean, it takes your advanced person to create a POC. Your normal APT groups, they're not caring about a lot of these low-level, outside-facing ransomware type things. But the script kiddies, yeah, they're going to come out and they're going to utilize a externally facing vulnerability that has an easy POC to then utilize, and from there, it's kind of the easy game from there. So it's really on your threat and vulnerability management team to help prioritize that, because it'll just fall on deaf ears at the developer and admin level. Great question, actually. Yeah. No. So for this, you won't get a lot of learning, because it's at the server level. So if it's used, we're using this example like from an on-prem environment. You have your on-prem IDP that is also helping to log into the cloud, but also even using Okta or something like that. If you are doing a dump of all the certificates, that will usually not call it. Now, if they're starting to do it now, and that's something that we have multiple IRs where we're talking directly with Okta, giving them like, hey, I think you guys should turn on these types of alerting. Those are the type of things that we've been talking with these identity providers, where they have those automatic alerts. But even then, those customer notifications that come in, who's a contact they're going to speak with, right? Is it going to fall into a Dropbox long inbox of security alerts? If usually by this time you should have already had multiple alarms set off before the attacker can even get into the IDP level, right? The IDP, as we said, should be tier 0, so should be really segmented away from your entire environment. But normally, most people have flat networks. I mean, how many times if you can get into the DC, you can get into the same server, you can get into workstation, you can RDP anywhere you want. There's no real segmentation that's happening. So this should have already tripped off a few alarms by this time, but unfortunately, you won't have a lot of alerts. But you can create these types of alerts when the certificate's being dumped, and that's where you can use, like, for example, if you're ADFS, you can use event like ID 1202, and where you can see the dumping of the cert util or export PFX. There's some open source tools that people utilize, and then you can see that in the actual event. Yeah, no, we're working with, during our IRs, we're seeing all these novel ways, and we're talking with the IDPs if we see something that, hey, you guys don't have it, or the cloud providers, right? The cloud providers should also have something on their end to be able to see it. So something we've been speaking with Microsoft and Google and AWS to help with their detection techniques. So hopefully it does take some time, but yeah, I think this is something that we're going to see for a while. So trying to create detections in the meantime is really going to be key. And I guess we're a little bit above time. Alrighty. Any other question? I'll be more than happy to answer the questions, but I think my time is up. But if there's any questions, please feel free to ask. Awesome.